Okay, so in this video we're going to go over the tutorial number 6, and the example will be the LED controller, the first example. You can see this example, in a bit more detail in these notes right here. It is just a simple LED controller with some counters, state machine. The difference is that we managed to partition, of course, the design into what we call the dynamic or runtime modifiable portion, which is right here, called the reconfigurable partition or RP. Okay, and the static portion, which is the part in blue, including the NOT gate and the state machine. Okay, so every time, this whole thing is actually static. And the way we created the file structure was like this, right? There's a top file, of course. There should be always a top file for everything. There is something that I call the static part, which includes this gem pulse, which is a counter, the NOT gate, and this state machine. And then there is also this portion here, the reconfigurable partition, that I have decided to use the name count_rp for the top file. And the idea is that in this top file, the parameters that we could modify to generate a different version of the reconfigurable partition, those parameters can be modified there. And of course, underneath there are a bunch of other BHDL files, including another gempulse block, of course. Okay. This block here has the count RP, has two parameters, count and dir, for the direction, right? Let me just see if I can show you very quickly before we continue. So this block here, the count RP, is just a wrapper file where you can modify the parameters. And in this particular case, there are two parameters that we can modify. First is the direction, whether we count up or down, and the count itself, okay? Which can be, whatever number you like. Okay, so that is that block. So when we created this design, of course, we arranged the files in this way, such that the reconfigurable portion right here is actually exposed. This is what we call by exposed. It should have a top file, right? Usually I attach the the RP label here, just to make sure that, to indicate that that is a top file of your reconfigurable partition. And the way I am going to work this example out is like this. Even though we have two parameters, for this example I plan to use to only generate two reconfigurable modules, okay, based on the RP. And each module will be like this. The first module will be generated when the direction of counting is up, and the second module is when the direction of counting is down. Okay, and here is the structure that I created, right, for the sources. Sources HDL, the top, those are the design files, these three files right here. Now the first reconfigurable partition, count RP, and all those three, right? Again, this name, of course, is up to you. You decide which name you prefer, right? As long as you indicate the same name in the Tcl script file. And the same for countdown. So in this folder, the RP has the count RP file has the parameter dir as up, and in this other folder, the count RP has the parameter dir as down. We can verify this, right? We go here and right here. There you go. Down, as I said. We are keeping this number fixed, okay? But I mean, you feel free to modify it, okay, if you want more variations, okay? And of course, we have also the XDC file. Here I have to make an observation. The question is, how do we get these files, this structure? Well, you can download, by the way, this from the tutorial site. You can download the folder structure, okay? But be careful here, because the folder structure as it is, right, are for the ZYBO board. What is the difference? The XDC files. So here, I actually here created my own top_IO XDC file for the ZYBO Z7. Okay, so what I do, I'm gonna right now actually cut and put it in sources XDC. I'm gonna replace it. Okay, so because now we're trying to use the ZYBO C710. If you are using the ZYBO, you don't need to make any change. Okay. Well, this top, by the way, still belongs to the ZYBO. You, in theory, will need to create your own for the ZYBO 10, but in this particular tutorial, I don't plan to use this file. Okay, I only plan to use this file here, and yep. Okay. Okay, so let's continue then. What else is there to explain? Well, another thing. I think that's it. Well, I think now we can actually start the process. Okay. Because we already have the where is it? We already have the structure. Okay, and like I said, there are two methods. Let me repeat again. There is what we call the design complete Tcl. You can run this file, runs everything, like I said. However, only works when the the RP, the reconfigurable partition constraints are known. Okay, and like I said to you here, I mentioned this already, by the way, in a different video, but just in case, this design complete Tcl file uses only the top XDC, which is supposed to be a combination of the top IO XDC plus the RP constraints, which of course, because I know I've done it before, I have saved in this pblocks XDC already. Okay, so that's the first method. We are not gonna do this method, by the way, because well, I only have to write one command, right, and there is nothing to learn there, and also because for the most part, I mean, you will usually not know these constraints ahead of time, by the way. That's why you cannot run this. To run this, you have to run this, once before, where you actually set up these constraints. But instead, we're gonna do the following. We're gonna run the design Tcl file, and this one only runs the synthesis, by the way. And of course, it uses only the top IO XDC, and you need to indicate the RP constraints. I think it's better to say you need to set manually, of course, the RP constraints and save. Okay, you can save this, as pblocks.xdc or as any other, file. Now remember, if you plan to use this, well, of course, you still need to modify this, right? Because, like I said, the files are for ZYBO. Okay? But anyway, in any case, let's just do, what we plan to do in this tutorial, which is use this file here. And I have already replaced this file for the ZYBO C7. Okay? So now, this is we will use this. Okay, so what are the steps? So you will see in a moment that it's actually, this looks a lot like a recipe. if, let me see, if you created your project in a, if you created your project as a non-PR project, sorry, let me see again, let me remind you the steps, just to create your project with the reconfigurable partition exposed, right, as a non-PR project, as a simple Vivado project, right? Once you do that, simulate. Notice that the important part here is this. The RP has to be exposed, like here, right? You have a file, a top file for your RP, where you can modify the parameters. That's what I mean by being exposed, okay? That might be easier said than done, by the way. That might be a little bit challenging. And then after that, what do? We create the folder structure for the Tcl PR flow, including, of course, the sources folder, right? So you create all of this, right? Each, of course, applying a variation for each case, right? That you want. And then what else? Well, then the next step, of course, is to create the Tcl files. So the design Tcl file, or if you like, the design file. So notice something interesting. Here we use count up and count down. Top is top, always that the name should be kept, by the way. By the way, this structure, I mean, the only reason we have this particular structure is because the Tcl file has determined that, okay? But for the reconfigurable partitions, you can select the name that you prefer. But of course, they should match the one in the Tcl file. And this is the Tcl file, by the way. It has a bunch of things. I mean, I only going to focus on what is important. The device is here. That's important, the package and the speed. These two, by the way, these three, sorry, they are the same in the ZYBO or the ZYBO Z7. So you don't have to change it, okay? And the flow control, what do? We are only doing synthesis, by the way. For the top file, the static portion, and each reconfigurable module. We are not doing these three, right? Because as I said before, we are going to follow this, the design Tcl, right? We are not going to do everything because we can't. Well, I guess we can, but that is not the purpose of this tutorial. Okay, and then here you see, these are the output directories. This is the reason I have a particular name for the folders. Okay, and then also the input directories, HDL, all of them. There are more that we don't use, by the way. This one is the same. Everything is the same, by the way. What is the difference? Well, top is top. By the way, you can change top to, I don't know, whatever it is you like, but I will keep it as top. The static portion, you keep it as static. Everything else you keep the same, by the way. Forget about this, by the way. This is a previous example that I just commented out, but here is my reconfigurable partition. Each reconfigurable module definition within the reconfigurable partition. We only have one partition, which is called count RP. This has to match. Has to match, of course, this. Sorry, has to match this file, by the way. Okay. It has to match that file. And then the variation for each one of them is actually count up, in this case, or count down. If you decide for these two, of course, you need to now create a folder named exactly like that. Okay. And you can create more, for different variations. Okay. And then after that, this is important, the module instantiation. What is that, by the way? Well, it's simple. me see if I can find this for you. If you go, for example, into this structure, right, the top file actually it is port mapping this block, right? And remember the label that it had. What do I mean by that? Let me show you in a moment. Let's go to the block sources. Because let's go here. All right. Look at it. The counter P here. This is where you do the port mapping for the counter P, right? But look at this. GA is the label, right? So here in your Tcl file, make sure to include GA. Okay. And then everything else, I think that's, to be fair, I believe this is all that you need to change. Of course, you create more of this according to the different RPs and RMs that you might have, of course. It's up to you. And then you do configuration, which I think you just create one, for the first module, the first variation, the first module, second variation. So one per each one of them. And that's it, to be fair. Everything else is the same. You will see in a moment that there is nothing that you need to change. You only need to create more of this, right, with different numbers here and here. There is no need to modify any of this, by the way, at all, or this. And then you create one of these for each reconfigurable module within each reconfigurable partition. But you need to change only what? This, right, and this. That's all. Okay. Once you do one or more, once you do one example of this, I mean, you will see how easy this is, by the way. It's not really hard. Okay. So we're gonna run this. In theory, this should run everything, but you will see that it will only run the synthesis. So it will synthesize what? Each partition, each module, this version, and the static portion, That's what it will synthesize. And it will place, of course, all the results of the synthesis. Guess what? Where? In synthesis, okay? This will be populated with synthesis files, okay? So that's what we're gonna do. I'm gonna do that slowly. So if you go to the tutorial, here you will see, everything that I just talked to you about, and well, here it is, and you will see this is just like a recipe. Okay, so what do we do first? Well, we have to actually need to run this design Tcl. Okay, how do we run it? We have to open a program that is called the Tcl shell. This part might be a bit, a bit annoying, to be fair. So now in your Windows, you have to look for Vivado Tcl shell. Let me see if I can. No, probably not. I'm typing, by the way, Vivado Tcl shell. Just type Vivado TCL. Oh, no. I think you better. It doesn't show on that screen. I am really sorry. But I think the way I did it is like this. Vivado 2.19.1 Tcl. I think if you type that, Vivado 2.19.1 Tcl shell. So the program is called Vivado 2019.1 TCL shell. Okay, you have to look for it, of course. It's an app. Once you click on it, I just click on it. It will take a little bit to open. Okay. So you have to run this. Right. To locate it in Windows. So here it is, and here is the important part. You need to, and this is the part that it can be a bit annoying. Navigate to the directory. So what is the directory? The directory where I place my design. So I downloaded, like I said, a zip file, right? And I unzip it here. my file structure. And of course, remember what I did a moment ago, right? I actually replaced the top IO XDC, right, for my ZYBO Z7. So, but I need to now navigate to this folder. That part can be a bit tricky, depending on your system, by the way. It's not the same, everyone. So you do, you unfortunately, you have to use commands, I guess, from sort of Linux or the old DOS. Let me see. So I'm here. I'm gonna go to, it's called ZYBO, and then you go on to my DYN LED. Now I'm there. Okay. So now, at that moment, I have to actually synthesize, right? Because I already have it ready. So what do I do? Oh, just source design equal. Not trace is such that it doesn't show a lot of messages. That's all. So it will synthesize the design and create output files in the synthesis folder. Depending on the size of your design, this might take a little while, right? Because remember, it is actually using Vivado to do the synthesis part. Okay, so like I said, it is actually right now, it is actually creating the synthesis portion. So it is placing stuff here. Oh yes, it's already working. You see, it's creating some files, and it will populate all of these three. The design complete Tcl will actually populate everything. But like I said, the problem is to run the design complete Tcl, you gotta have the RP constraints already ready. And at the beginning, the first time you run this, you will not have those. That is the problem. Okay, so let me see, what do I have? Like I said, it takes a while. The larger the project, the longer it takes. And believe me, all of this is just to refer copying and pasting all of the commands. The only portion that might be a bit, I would say, challenging is setting up the reconfigurable partition constraints. This whole thing. That is the part that might be a bit challenging in some cases. Okay, can really be very. Sometimes it can be difficult, by the way, because the software doesn't work or doesn't behave as we would like usually. So let me do this. Okay. So again, if you had already the reconfigurable partition constraints, I mean, this part would be skipped, and and you can actually run all of these commands automatically, not one by one like I'm gonna do here. The reason I am doing one by one because you need to do this anyway, at least once the first time you run your project. But then B, because I need to explain at least what these steps do. Okay. Okay, let me see. No, there you go. Okay, it's it completed. Okay, so now you have in synthesis these things, this DCP. Remember, I think I mentioned in another video, right? Once you go here, what do? You run the design Tcl. It will synthesize the static region and the reconfigurable partitions, and it will create DCPs, which are actually checkpoints. What are checkpoints? I think I mentioned this before, and it's in the notes. It's just a snapshot of your design at a particular stage. It could be after synthesis or after implementation. It's sort of a netlist file, by the way. Okay, very important, by the way, very, very important. So now we created that. Now we're gonna follow this tutorial. What do we do? Well, we have to start actually the GUI, which means Vivado will open in a moment. Let it open, take a while, and after it opens, I am actually going to let me see. I am actually going to open the checkpoint for the synthesis. Okay. So let me explain to you what that is. The first command is this, right? What is that doing, by the way? It opens the DCP, or yeah, the checkpoint, the DCP of the static region on it. Okay. So we're here. So we open Vivado. This is a normal Vivado. So we're going to actually here in the Tcl console, we're going to write that. Okay, we already have it. Synth static top 3. There you go. And it will open that checkpoint, by the way. Okay. Let's give it a little bit of time. It's going to take a little while, unfortunately. There you go. Notice that there is a warning here. That's okay, because you see the counter P, apparently it doesn't exist. And it's GA. Remember what I mentioned about GA? That is the label in the port mapping. Okay. So look, this is the top file, and look at here. Look at the GA, the one that belongs to counter P. It's actually blacked out. That means that it is actually empty, right? That's what it means. Okay. So keep that in mind. Okay. So what do we do next? Well, we have to, what we see, create our what is it? Our first configuration. And for the first configuration, we're going to select the count up. By the way, you can do countdown, by the way, but that will be our first configuration. So what do we do to create the first configuration? We have to, of course, fill up this black box. Okay. And what do we do is we use the command read checkpoint. We're going to actually read right on this cell GA. Remember that's why GA is very important, right? That's the port map label of your counter p.vhd. We're going to load this file, the checkpoint for the count up. Okay, so that is what we're going to do. Let me see. So that's what we're going to do according to the tutorial, right? The tutorial says as much. Tutorial. This is the GA is the instantiation name of the VHDL code, the port map for the counter P VHD files. So we're going to actually do that. Okay, we're going to load in, okay. And this thing is going to now fill up. You will see in a moment. Yeah, there you go. So now it actually has some stuff, right? Whereas before it was actually empty. So that is our first configuration. But of course, we need to do more than that. And all the steps, by the way, I'll explain here. I'm going to skip them a little bit, but let me see. No, sorry, I'm not going to skip them. I'm going to skip the explanation right there. So what do? We have to set, and this is the thing, we have to set the GA, which is the counter P, as reconfigurable area, as a reconfigurable partition or area, if you like. So you have to use that. But that's nothing. That's actually pretty straightforward. There you go. And then, what do you have to do? I'm not sure. I mean, if you want to, as an option, you can actually save this checkpoint, right? This is static. That's the RP with a count up. Okay, that's what we are going to do now. Okay, it is important to sometimes it's important to save that. In case, for example, it happens a lot that we're doing this and all of a sudden, Vivado crashes, right? So you can always, start from here, right, by opening this checkpoint instead of writing it. But now we're going to save it, okay? It's not actually, to be fair, mandatory, just in case. Okay, so what is now, here is the really messy part. Sorry. We have to, all of this is just a fancy name for setting the reconfigurable partition size. Okay. That is going to be problematic, and you might need to spend more time than you need to. So what is the next step? After this, you have to actually assign RP constraints. Right. That's the real difficult part. And I don't think you can do this automatically because you have to run a design rule check every time. Let me tell you how to do it. Essentially, you go here, right-click, floor planning, and then you say draw P-block. But before we do that, let me maximize this or make it slightly bigger. That's the PSOC, right, that we have. And I am going to do this and draw P-block. And the following will happen. Look, you can actually draw an area for that particular reconfigurable partition. How do you do it? Well, here I say, oh, this. How do I know if that's enough? By the way, click OK here. How do I know if that's enough, by the way? Well, if you go here to the P-block properties, they will give you an estimate. Like this thing is occupying like only, will need 18% out of this area. Your hardware will need only 18%. I think I've done it up to 80% in the worst case. I think it still works. I mean, don't go more than 80, by the way. Okay. And well, you would think that this is it, by the way. But the problem is, and this is just, I guess, because of limitations in technology, that the problem is, as I explained here, now you have to run the design rule check. Okay, let me see. Assign constraints. Here is an important point. Select the size of the largest power. Okay, usually this is not a problem, by the way, because in this counter up and down we kind of guess that they are the same size. I don't think it matters. But you will see in other examples, it is important that you use up as your first configuration, right? Let me see. Use the configuration with largest, I guess, expected size, okay? Because you only get to define that at the beginning, and then, if you, don't allocate enough space, you might have a lot of problems, further up. So that's what we're going to do. So the problem is that now we have to run a design rule check. And the problem is that it is extremely, this software is extremely picky as to where you put this area. Okay? It's going to give you weird stuff. But let me try it. Report. You go here to report DRC. By the way, do this every time. Otherwise, it will not work. I guarantee you. Report DRC. Give it a moment, and then it will just run a DRC check, a design rule check. And unfortunately, this might take me a long while. It depends. Forget about the. Only focus on the partial reconfiguration, by the way, violations, okay? Let me see. Focus on partial reconfiguration violations. And I think I mentioned here in the tutorial which ones to look out for. This is the HPR 26 and 8. Those two might be, by the way, problematic. Okay, if you have them, be very careful, okay? Especially the 26, by the way. I hope I didn't get that. Let me see. What am I getting? Oh, the 8. Huh. Well, that is telling you the following, that the reconfigurable partition doesn't have a reset. So in this particular example, I am getting the following. 8. RT does not have reset. Or I think it's better to say it doesn't have a software configurable reset. So that is a problem, but it is only a problem, right, when you have flip-flops, right? Which of course we do, unfortunately. Also, notice something else. I mean, yeah, it is a problem, true, but remember, this is a visual application, right? Does it really matter if at the beginning these LEDs are, instead of starting at 0, 0, they start at 1, 1? It doesn't, right? Because it will be too fast that we won't even notice. And that is what this tutorial is saying, right? For HDPR8, software controllable reset missing. This is not a problem in this visual example, okay? In other examples, like if you have a state machine that is controlling, like a Cordic or a divider, oh, please be very careful there, because it will be an issue there, okay? So we have that, HDPR8. So as I say to you, we're going to ignore that, okay? And this is the real deal, HDPR6, 2026, I think. Okay? I still don't know how to fix it. I mean, there is a way to fix it by using the snapping mode on. I particularly don't like it because it might create more problems. So what do you do then for that particular block? Let me see. Just a moment, sorry. This part deserves a lot of attention because it might be problematic. One way, I mean, if you really want to get rid of it, you have to click right here on this block, go to, I think, properties, and then you can here do a let me see. Oops. You can put the snapping mode on. All it means is the following: that it will automatically avoid some areas that the compiler doesn't want you to have. And to me, that might work. I mean, that might work, by the way. But I have noticed that in some projects, right, it might increase the area that you need, which is okay, by the way. By the way, if you are just learning this, I would recommend you just do the snapping mode on. But in my case, I am going to try to actually fix it. There are many ways to fix it, by the way. Let's see. No, this doesn't work anymore. It used to work. Okay, I can. So I can enlarge this. I can do it here. And let's see if that works. Sometimes in my computer it even crashes when I try that, by the way. If I play with this thing too long, too much, they say that the right edge, apparently, you see, it didn't like my right edge. That's the problem. That can be problematic. So now I change it a little bit. By the way, sometimes it might not work, by the way. So that's why sometimes what you should do, you delete this and then you start over until you find a proper position. It's really hard to know where it is. Like I said, in most cases, like I said to you, it is better to just use the snapping mode on. But sometimes I have noticed that might create more problems. This is why this part here is the most critical one. If you pass this part, you are fine. So now let's try again. So let's do reports, report DRC. I'm going to use the same one. Let's see if this is going to work or not for us. Oh no. You see, I might be here forever, you see, for a long time. Now it doesn't like my left edge. See, this is why I'm gonna just change my left edge to. That doesn't mean, by the way, it's gonna work, but at least we can try, right? Let me try again. Yeah, you see, now we got rid of that one, but because it sometimes it doesn't like you do your left edge or your right edge. Sometimes it doesn't like both. I mean, it's annoying. Okay, and like I said, focus only on this one. The pin planning, don't even think about it, because we have not yet defined those. That's not a problem, please. Okay, so we're good. Okay, but believe me, if you're working on a project on this part might take a lot of time. Can be very a bit disappointing too, by the way. Okay, the HDRP 26 warning, fix it carefully by expanding or contracting edges, okay, of your IP. So now I think we are good to go. So now actually we can I think if you manage to pass, I think you please save it. Okay, you please save. Let me see. Sorry, it's taking more than expected. There you go. That's the next command. So I'm going to save those constraints just in case, because I already know that this is going to work. Okay, I saved them. So now, to be fair, let me tell you something. At this moment, actually, what you can do, you can graph the these constraints that you got. Let me show you here. They are constraints only. They say the region that you need. Okay, that's what they say. But at this point, you can actually do the following. You can grab flang and these two, and you can merge those two. Just copy one after the other, and you can merge that into top XDC. And if you do that, you can actually run design complete. Okay. If you merge flang XDC plus the top IO XDC, you can just run the design complete. This is why I was telling you, really, the really important part is what we just did, is to assign the RP constraints, because everything else is going to be, by the way, from now on, very mechanical. Okay, but of course we're going to pass on that just to show you, the remaining steps. Okay, but yes, you can definitely do this now that you have the constraints that we want. Okay. Okay. So then, what do we do next? Okay, we have to prepare the. We have to prepare our first configuration. It's not ready yet, by the way. Okay, because we defined the constraint, but now we need to actually what? We need to now assign the IO constraints, right? Because this particular project has IO constraints to the PL. Assign the PL IO constraint. Okay. Those are just, simple constraints that you know about, I think, here. Right? The clock, the enable, all of them, they are defined there, of course. So now what else do we do? So now, actually, we are ready to implement our first configuration, because once you define that, right, what do? You have to do all the steps that we do. Optimize, place design, and route design. Let's hope, this is okay. You never know, right? Something might might always go wrong, but optimize, that should be easy. Takes a little while, and then you do place. Make sure, of course, that you don't get any errors or even critical warning. Place design. Those are typical steps, by the way, that are wrong when you click on implementation. Okay. Might take a little while. And then you do, let me see, route design. Okay, so sometimes it is here where you might get an issue, right? It might not actually route it, so there's a mistake. But let's hope that there is no mistake there. Okay. So it will create your first design properly routed, right, in the FPGA. I mean, where all the FPGA resources have been already allocated. Okay. Okay, so here we are. You see here? You can see here a little bit. It will let you know what parts are allocated, by the way, in this picture. Okay. So what do we do next? So we are almost ready, by the way. So now what we're gonna do is we are gonna save this as a checkpoint, just in case. Right here, you see implement config count up. That's what I do. I'm gonna save that one as a checkpoint. There you go. Then, by the way, this is not really necessary, but it is in the tutorial. You have to, save a report of utilization if you want to. It's not a big deal. It's not really necessary to be fair. And then also, save a timing report. Okay. So here is the important part, what I wanted to mention to you. What should we do next? Now we have to get the truly, what we call the truly static design. What do I mean by that? Well, this is what I'm gonna do. I am gonna actually do the following. Remove the RP from this design, the one that I have right now. And then I'm gonna lock the IOs of the RP. I'm gonna just make sure they are always in place. And after that, I can actually save that design. Okay, save this truly static design. This is the one that's actually very, very important, because from there you can create any variation for your RPs. Okay, so that's what we're gonna do. Why do we call it truly static? Because we have already the design already routed, and this thing is gonna be kept in place, but we're gonna remove, of course, the RP, and I'm gonna lock the IOs of the RP in the position that we want to, right? And then we just save it. Okay. So this step, by the way, is very, very important. It's a bit misunderstood, but yeah, it's very, very, very important. This thing takes nothing, by the way. It's not a big deal. And then you save. There you go. Okay. So now we are ready to continue. So what do we do in the next? So now remember, you see GA, which is the counter P, is actually now empty again, right? So what are we supposed to do now? We need to, we need to, we need to do our second configuration, right? Which is the count down. Okay. What do we do there? There are many ways you can do this. One way to do it is to do close project, right? And then what you should do is just let me see. Oh, you can always do this again. Open checkpoint, right? And that would be this, the static one. And then once you open that checkpoint, you need to read in or kind of load the second configuration. Read checkpoint this part here, right? So it is loaded with the second configuration, which is a countdown. But notice now, since we already have this open, right, there is no reason for me to actually do these two steps, right? Because the design is already open to me. Yeah. Okay. Let me see. So that's one way you can do it, by the way. Okay. What else do I want to say here? Yeah, that's one way to do it. Okay. Okay. So now what we're gonna do is to actually load our second configuration, right? Because the design is empty, but now we're gonna load the countdown, our second version. So this thing has to now be complete. So now we have what? We need to optimize the design, like I said. Oops. Let's give it a little bit of time. We need to place the design. And then the part that takes the longest will be the route design. Okay, so now we have our second design ready. So after this, you do optimize design, route, place design, and then route design. Okay. Okay. So what is after this? I mean, sorry. I guess I'm getting ahead of myself. So then after this is completed, you have to save it, right? You have to save this checkpoint, right? The countdown. So I'm going to save that as a checkpoint just in case. And I'm going to, even though it's not actually needed, to be fair, save the utilization report. And then here I'm also going to save the utilization, the timing report for my second configuration. Okay, and I will proceed with a similar process, for any other configuration that I might have. So if I have that configuration, I don't know what it will be, but what you would do is actually the following. Here you have two options because the design is already completed. By the way, be careful. You can do close project, and then you can do again, open checkpoint, and then read checkpoint, and here you would, I guess, you will need to load, your own, another variation, or whatever you like. That's one way to do it. Another way to do this by this. Instead of these two files, you actually are going to do the following. You remove the black box, right? So yeah, the RP, and then you run this again. Right? Either way, it's the same. It's going to work the same. Okay, but of course we do not have, right, a third configuration. We only have two. So remember, you can do either of these, right? This is, I guess, first option, and this is second option. But we're not doing that at all. Okay. So now, what is the next step? Because since we're done, almost done by the way, we want to close the project. Like I said, if at any moment you something happens with your computer and it crashes, remember that you already have the checkpoints, right? And you can always start over from the checkpoints using the open checkpoint. Okay. Especially, by the way, if you're already here, if you really get the truly static design, that's actually a lot, by the way. And from that, you can actually do a lot. Okay. Okay, so now, well, did I do this already? Yeah, I'm gonna close this project. There you go. And then, what is the next part now? Well, the next portion is just what we call generate the bit streams. Okay. And before that, we have to run a utility that is called verification. That happens in case, in case you made a mistake somewhere along the way, and the two variations, right, do not have the same IOs for some example. By the way, it happens. Believe me, it happens. Just in case you run it, and it will do that verification for you. So now when I run this, it will take a little while, yes. And after that, we are ready to generate the bitstream, which is by the way the easy part. The difficult part has already been completed. So now, how are we gonna do this? Let's see. For the first bitstream, the way you do it is by opening the checkpoint for a particular configuration. In this case, we're gonna start with the count up, and then all you have to do is to just execute this command, write the bitstream. It will generate, by the way, it will generate the full and partial bitstream, okay, of that particular version of the hardware, by the way. Okay, and I guess you know what's going on, right? The second bitstream is going to be the same, right? You just the same commands, right? There you go. But in this case, it is count down, right? It's a bit different, of course. Okay, so now let's run this, okay? Let's open first the checkpoint, because apparently this is okay. They said these two are compatible, so we're good. Okay, it will tell you there is an error, by the way. So now here we just open the first checkpoint for my first configuration. It will open a different window in Vivado, by the way. Make sure you are in that window before you execute the next command. There you go. And then we're gonna do this, right? I'm gonna write the bitstream. There you go. Oh, let me see. Something happened. Let's take a look. Okay, let me just okay, so well, apparently there is an error here, and I guess this is a good I guess this is good, because I can show you what you can do to fix it. So you've seen all the steps already, which should be, like a recipe, but from what I see here, apparently I forgot one step. Let me see, and let me show you quickly here. I did all of that, but unfortunately I actually forgot to assign the IO constraints, even though I said that I would. How do I know? I can always go back. Look at it, all the way up until the first one. You see, I did write XDC, and then I directly optimized. I didn't actually read in the XDC. So now, what am I supposed to do? Well, essentially you have to start over, sort of. I'm gonna do something here. Remember this checkpoint here, right? We have to start from here. Okay, so we're gonna do this, but of course instead of write, I'm gonna open that checkpoint. Okay, so now after this, you need to assign the constraints. That's what it looks like, right? Just a moment here till I find this. taking a little while, more than expected. Here you go. Okay, here I go. That's what I have. So I have to assign the constraint. But remember, I don't need to anymore, right? Because I already saved those constraints, right? So I'm going to actually, instead of write, I am actually going to read the constraints. Okay, that is much better. See, you see how this box appeared already there. Okay, and then of course this time I am not going to forget. I am going to read in these constraints. Those are the I/O constraints. Oops, something is there complaining about something in the constraint file. Apparently there was a mistake. But this is not good. What is it? Okay, by the way, this is very weird, but it's good for you to know. If you see this, somehow there is a weird symbol into the text file, right? Be very careful, okay? It's not gonna work. I look into my file, right? Top IO, and I actually didn't see anything, right? Like that. It looked okay to me. So I tried it so many times that it didn't work. So what I did was actually something very weird. I opened this one here, right? Sorry. Copy and paste it into a new file. This, right? Sorry, I deleted the previous file, and then from this file I generated this new file, but with the actual IOs for the ZYBO C7. Essentially, yes, what I want to tell you is, and I think it is good that this happens, because Vivado is doing something stuff that is very weird. I created the top IO etc for ZYBO C710, right, on a Windows 8 computer, and I got this weird error, right? The one that I just mentioned to you right here, right? I got it so many times. I try everything, believe me. So what I did, even though it's gonna look very weird to you, I created the top IO etc in this Windows 10 PC, and it works, believe it or not. Okay, so this is why I usually don't like this software. It's has a lot of bugs, and it's very weird, to be fair. But it is good that this happens, so you know now. So I created a new file, so now I can run it again. By the way, if you don't believe me, you will see that there are no warnings. There is one warning, because it means that I already did it, so there is no reason to do it again. But there is not that warning of the weird character. Okay, so I guess be careful with that. By the way, sometimes I have experienced that when I copy and paste from here, by the way, into the tcl command, sometimes it says that there is an error in the command. There is something happening with the text file. Sorry, with the text. Okay, be very, very careful. I am really sorry about this. This is why I think what I am following right here is actually, I am writing it in a text file here and then copy and paste. I am not copying from the PDF file. My guess is that the problem is actually my Windows 8 computer, to be fair. Okay, I think that's the problem. But I think if you do everything in Windows 10, I think it should be fine. Okay. Again, I am really sorry about this, but it's good to know all the bugs of this software. So now once you do this, now you do optimize place and route. Okay. So now we're gonna do place. Okay, and then we do the route design. I think to be fair, the route design, it did tell me that there was an issue with the IOs, but I guess I have been doing this so many times that I just didn't look at it. Okay, but it's good. At least we know, the errors and that. By the way, you most likely, if you are doing this for the first time, you will face some of these issues yourselves. Okay, so let that finish, and then we're gonna actually save the checkpoint again. There are no warnings luckily for us. I think I should have known before. Okay, so we'll save that one. I'm gonna skip the text files, we don't need those reports. I'm gonna do update. Right, remember to remove the reconfigurable partition and then to lock the routing, and then finally we have this is a super precious file, which is the truly static design. Okay, and now we create our second configuration by just filling up the RP with the second variation. Okay. Once we do that, well, we will set up optimize design. We do place design. It'll take a little while, and then we do route design. Then we're gonna write the checkpoint again. So it's ready. So we write the checkpoint, and then we're ready to do do the bit streams, right? We're gonna verify again, of course, because everything is known. Back here. Let's hope this works fine. And after that, of course, we wanna create the first bit stream. Okay, so everything is okay according to this, compatible. We open the first checkpoint, of course. Make sure to make a new Vivado window will open. Make sure to be located at that window before you execute the write bitstream command right here. So then we're going to now open this checkpoint. Sorry, we already opened it, right? So we're going to do the write bitstream, and it will generate both the full and the partial bitstream, by the way. Let's see. Yeah, it's complaining about that there is no PS, but that's fine, right? Because there is no PS, of course. It's absolutely fine. So now we have to go into the bit streams, and just give it a little bit, and it will generate the bit streams that we want. Okay, give it a little bit of time. This thing takes a little bit long, unfortunately. So according to the tutorial, you have to do all of that. Let me see, right here. Just generating the bit streams. Now Yeah, you can see them here, right? This is the full bitstream, the one that configures the entire FPGA is about 2 megabytes, and the partial one is only about 115 kilobytes. You see, that's why it's called partial bitstream. But that is for the the first configuration, right? Now we have to do the same, but for the second configuration. So we're gonna close this project because we need to open a different checkpoint now. The second one. Yep, countdown. Okay. Once we do that, we're gonna do this. I'm gonna write the bitstream. Again, make sure to locate in the new window that will open, the one that shows the second configuration floor plan, this thing right here. You locate right there, and you are gonna now create the bitstream. Okay. So after that, and this is just for fun, by the way, this is what we call we want to create a blank bitstream. Okay, that means it's a bitstream that will, if you program that bitstream, what's going to happen is that the RP will be empty. Okay, there will be nothing there. It might be useful in some circumstances. Okay, so now let's see. This is going to take a little while, of course. There you go. It's already creating the first down full bitstream. Let's just give it a little bit of time for this to complete. Okay, so now we're good there. So we're gonna close this project. Now please just take a look. Now you can see here the down bitstream as well. Okay. Okay. So we're good, right? This is very good. So now to generate the bitstream, the blank bitstream, we have to of course load remember the truly static checkpoint, right? That's what we do now, because that's the one that doesn't have anything on the reconfigurable partition. Now, apparently we have to do this. This is something very important. We have to, let me see, and it is explained here, by the way. Removing the buffer ports inserts constant drivers on the output so that they don't just float. Okay, that's what they are doing right there. So once we open the checkpoint, we just because the checkpoint, this is a truly static one, we have to just do the command, the buffer port, that inserts ground on the output, right? Is that what it said? Yeah, so that they don't float, right? So there are constant drivers on those outputs. Okay, and after that you do place and, of course, you see, you do place and route, of course. Is it here or here? Yeah, here. Remember, it has to be here on this window. Then you do place the sign. There doesn't optimize, I think. Well, and then you do a route design. It's gonna take a little bit, and then you have to, of course, save that particular checkpoint, which will be the one of a black box, right? That's the one that we need. Like I said, this step, by the way, is just optional. But in some circumstances it is useful. Like if you are having an entire system running, and let's say you do not need that portion to be run for a long time, right? You can just blank it out in order to save energy consumption. Okay, that's one reason it might help. There you go. So the routing is done. Now we're going to save the checkpoint. And since we had the checkpoint already open, we can actually just directly generate all the bit streams. So that will take a while, but it will generate all the bit streams. And after that, I think now you are ready, and we are ready to program. Okay. So you see, it's actually, I mean, it can take a long while, right, this process. And like I said, let's be very clear here. All of these steps, I am doing all of these steps only because, only because I decided, to run this one, the design Tcl. Okay? But I needed to, because otherwise I could have never assigned the constraints. But again, if you assign the constraints and you merge, your RP constraints with the top IO constraints on a, let me see, no, it's not input top. So you can just then, from this point on, you can just run this thing, design complete Tcl, and everything else will be run, for you. Okay, that's actually very helpful. Okay, but you need to do this part, unfortunately. Okay, there's no way around it. Okay, so now we are completed, I think. Let's see. Yeah, I think it completed. If you look into the bit streams, it should show you here, of course, the full one for the, that's the full bit stream for the configuration without anything on the RP. Whereas this one is the partial bit stream that will actually blank out a particular configuration. So a particular RP, the RP that we wanted. Okay. So now actually we are done with this portion. We're gonna close the project, and according to this, well, we need to test it, right? And again, we're gonna test it using a what we call the purely manual reconfiguration, right? That will be manual reconfiguration. It's called JTAG-based. So all we're gonna do is actually, let's see. We're gonna, of course, like program in Vivado, right? And we're gonna select at the beginning, just for fun, the config up bit. So what I'm gonna do here, I think I should go. Let me see if I. Let me see. Yeah, apparently something is still open, so I'm gonna close this project so that I can come back to the original Vivado. There you go. So now you can go into File, Flow. Let me see. Yeah, open Hardware Manager. Right. And it will take a little bit, and open target or connect. Of course, you have to have your ZYBO Z7 in this case connected. Sometimes this takes longer than expected. Give it a little time. Okay, so now we're going to program the device. But of course here you have to actually select of course, you have to select the full bit stream, right? You never select the, oops, you have to go to the particular folder here. And you have to select the full, by the way. You never start with the partial bit stream, of course. You can select, by the way, up or down, doesn't matter, or even the blank box. So, what should you be seeing? Let's see. Let me see. Here, you should be seeing that these LEDs are actually running. I don't remember to refer. I think they are doing 1001, 1001 all the time. Whereas this is up, they do 0001, 1011. But if this is down, it will go in reverse, right? And if I use a blanking bit stream, there will be nothing here. They will be 0. They will be off, the LEDs. Okay, so at the beginning, of course, I should see 0101 on the first two LEDs and then a count on the second set of LEDs. There you go. I programmed that. Yeah, I am seeing that. And then you need to, let's say, select the config down, for example, right? Just that departure one, a tiny one. And the count must change, by the way. You see? There you go, it did. And you can do the same with the blanking bitstream, by the way. If you do the same with the blanking bitstream, the black box, you should see nothing on there. There you go, there's nothing in there. Okay, so okay, in a moment, let me just right now in a moment show you the entire sequence. Okay, let me just start over with the config app again. There you go. Okay, so as you can see, this is the first configuration, and what I'm gonna do now, you can see the LEDs that go from 0001, 1011, and the other LEDs that go 01, 01, 01 all the time. That's the static part. The dynamic part is the part of the counter, right? That goes 00, 01, 1011. So I'm gonna now only program, the partial bit stream for the countdown. Let me see. Wait a moment, and I'm gonna click in a moment. But when I click, notice that the 0101 LED, those will never actually stop. They will keep working all the time, by the way. So here I go. Now you see now how the count now goes from 11, 10, 01, 00. Okay, and I can also do the following. I can now program a blanking bit stream, only the partial one. Here, here I go. You can see now how those two bits are off, right? But the other bits, 1001, they are still working. And finally, let's go back to the original one. I'm going to load the partial one for the app. And the counter app should appear now in a moment. Here I go. You can see them. Okay? And that's the example I wanted to show you. Thank you.